All right, so that was the name of the module you had to find. And now the next question is, which of these classes, because you see these are all the classes of this neighbors module. That's actually the name of the module by Scikit-learn, neighbors. And these are all the classes that allow you to build machine learning tools, in this nearest neighbors branch of machine learning. All right, so of course, the one we're interested in is this one, K-neighbors classifier. There you go. Congratulations if you found it. So let's click it and let's see the whole documentation. So feel free to read it if you want. You can see what are all the parameters and also attributes. But what we actually simply need is this, the whole name of the class and the module and the library Scikit-learn. Because the only thing that we need really to build and train this KNN model is the name of this class to, create the object and also the parameters here. We need to know which parameters we have to enter here in order to build a relevant KNN model. All right. So first, let's take this and let's go back to our implementation to here, paste it, and then adapt it by, doing this from Scikit-learn, and then from the neighbors module of Scikit-learn, we will import this class, the K-neighbors classifier. That's the class. And then, the next natural step, it is to create an object of this class, which will represent exactly the KNN model itself, the classifier. And that's why we call it classifier. And then to create an object of this class, well, we just need to call the class again. So I'm copying this, pasting it here, and then adding some parentheses. All right, so that's the first information we need to get from the Scikit-learn API. But then the second thing we need to check also are the parameters here. And you have all the descriptions here. So for example, the first one, n neighbors equals 5. N neighbors is of course the number of neighbors of your KNN model. You remember the intuition lectures. You have the neighbors that you use to make your predictions. And we have to choose a number of neighbors. And well, we can just try this value, 5. I actually know that we will get good results with this, but in your future machine learning projects, if you're using a KNN model, well, I recommend to tune it with several values. But 5 is usually good. So let's do this. First parameter, n neighbors equals 5. Good. Then next parameter, let's see. Weights equals uniform. So uniform is the default value of weights, and weights is the weight function used in prediction. And well, here we will actually keep the default value uniform, which means that all the points in each neighborhood are weighted equally. Okay, so they have the same importance. So we will keep that, that's fine. Then algorithm equals auto, what does that mean? Well, that's basically the algorithm used to compute the nearest neighbors, and auto is the best value to choose because it will decide automatically the most appropriate algorithm based on the values passed to the fit method, the method that trains your model on the training set. So definitely here it will be simple if we choose auto. And then you have some other parameters, leaf size, of which we'll keep the default value, and p, which is the power parameter for the Minkowski metric. So there we go. That's important. That's the other parameters we will enter. The last two parameters I actually want to enter are this one, metric equals Minkowski, and p. Because indeed, metric is actually the distance you want to use to compute, the distance between your observation points and the neighbors. And we actually want to choose the Euclidean distance, which is, the classic distance equal to the square root of the sum of the square differences between the coordinates. And in order to take that classic Euclidean distance, well, we have to choose a Minkowski metric with p equals 2. So basically, we're keeping all the default values of this K-neighbors classifier class, but in order to make sure that we are using them and just to highlight them, well, let's just write these parameters with their default values anyway, because it's important to see what we're dealing with, what version of KNN we're dealing with. Okay, so let's do this quickly. Metric equals Minkowski, and then p equals 2. Perfect. And so now we have basically a classic K-nearest neighbors model with 5 neighbors and the classic Euclidean distance. Okay? And now you perfectly know how to finish this. The last step here is, of course, to train our classifier, which indeed we built so far, but is not trained yet on the training set. So that's exactly what we need to do as a final step. And so there you go. We call our classifier, from which we're going to call our fit method, which as usual takes as input First, the matrix of features xtrain, and second, the dependent variable vector y-train of the training set, of course. All right, perfect. And that's it. You know, we are done with this implementation. All the rest is the same. We don't have to change anything else here. Because indeed, since we called our KNN model classifier, well, here, to make the predictions, we already have the right name of the variable, classifier. And then same here to predict the test set results, classifier. And then same for the confusion matrix, y-test, y-pred, which result from our same classifier. And then same for the visualization of the results. Sorry, I just showed them to you. I hope you didn't see, but we're going to get to that in a second. But there you go. That's the same. Same names of the variable, classifier, xtrain, y-train. So all the rest is the same. And that's why I like to call it a good code template.